Hey everyone, this is Connor Mead with the Calculation Center with another video on our Linear Algebra series. In this video we're going to be talking about multiplying matrices together. I've got in little brackets here that sometimes this multiplication of matrix is also called composition of matrix, or we'd be composing matrices together. But I think a lot of courses will understand what we mean when we say multiplying matrices. The important thing about matrix multiplication is it's different to number multiplication in the sense that it doesn't always make sense to talk about it. So what I mean by that is this sentence here. Multiplication of matrices, I should put in there, makes sense only if the left matrix has as many columns as the right matrix has rows. Okay? And I've got some examples of this down here. This left matrix here has two columns, this first one and the second one, and three rows, this one, this one, and this one. This matrix on the right has four columns, 1, 2, 3, 4, and two rows. Okay? So if we check our sentence here, multiplication makes sense only if the left matrix has as many columns as the right matrix has rows. Okay, so this is a three row by two column matrix, and this is a 2 row by 4 column matrix. So since we have 2 rows here and 2 columns here, it makes sense to talk about the multiplication of this matrix. Contrast this with this example over here. This is a 2 by 3 matrix. That's to say it has 2 rows and 3 columns. And this matrix over here has, it's the same matrix over here again, actually. It's got 2 rows and 4 columns. So matrix multiplication doesn't make sense here because this has 3 columns, but this only has 2 rows. Okay? And lastly, as my final example of something that doesn't work is, notice that this third example here is a 2 by 4 by a 3 by 2. But more specifically, it's actually we've swapped the order of multiplications of our first example. Okay? So we've got a 3 by 2 matrix times a 2 by 4. But down here we have a 2 by 4 times a 3 by 2. And although this first one made sense, even though all we've done is swap the order, this matrix multiplication no longer makes sense. So this is the general property in matrix multiplication that AB is not equal to BA most of the time. There's some specific examples in which this is true, but normally you can't swap the order in which you do multiplication, as opposed to with regular numbers. Okay, but again, just to be clear, this last one doesn't make sense because it's got 2 rows and 4 columns, but the thing on the right has 2 columns and 3 rows. We want to match up the columns on the left with the rows on the right. Okay, and if you use this notation where you denote it like, oh, for columns, you do this kind of dimension marking. This is 2 columns and 4 rows. You can kind of imagine, you can easily tell if things multiplication makes sense if the 2 numbers in the middle match up. So this is a 3 by 2 by 2 by 4. So the multiplication is okay because we've got a 2 here and a 2 here. And in fact, the matrix that will come out will be a 3 by 4 matrix. So you can kind of think of matrix multiplication as squishing down these numbers together, and all you're left is a 3 by 4. We'll see when we go through some examples that that's how it works. But this is just an important thing to always check if you're asked to multiply matrices together. Make sure it makes sense from the context. Make sure that you're allowed to do this multiplication. Now, the first step to doing multiplications of vectors is to know how to multiply matrices. First step to knowing how to multiply matrices is to know how to multiply matrices by vectors. Okay, specifically from the right. Okay, so here I've got an example of a 3 by 3 matrix and a 3 by 1 matrix. Now, often, if a matrix only has 1 column, we'll call that matrix a vector. Or, there's lots of different ways of defining vectors, but this is essentially what it is, and this is how we consider the multiplication. It's very simple. You might have seen some formulas for matrix multiplications, and they can get very complicated. So I'm going to show you guys a way to do it quick and easy without having to memorize any arduous formula. The only thing I'm going to ask you guys to remember is that if we're multiplying a matrix by a vector, that is to say we have a 3 by 3 matrix here and a 3 by 1 vector here. This makes sense because this matrix on the left has as many rows as this, has as many columns as this matrix has rows. But the easy way to do this is basically you take the first number of your vector, 1, and you multiply it by the first column here. You take your second number here, 2, and you multiply it by the second column. And lastly, you take your third number, 3, and you multiply it by the third column. Okay, so this just tells you how much the kind of vector on the right tells you how much you have to multiply each of the columns by, and then you add them all up. Okay, so what do we get here? We get 1 plus 2 times 3, plus 3 times 2 is 6. So this is 12 and 13 on top. If anyone has, hopefully you guys are familiar with how to multiply and add vectors together. 2 plus 0 plus 6 is 8. Minus 1 plus 8 plus 6, so that's 14, 13 again, I think. Okay? And this is our product. So notice that we, and this is again a 3 by 1 matrix. So notice that our 3's in the center cancel and we got a 3 by 1 matrix in the end. Okay, and this is how we do multiplication of vectors by matrices. To talk about the next section, we're going to need to talk about how to multiply matrices. Now again, we have to check and make sure our matrix multiplication makes sense. So we got a 3 by 3 matrix here and a 3 by 4 matrix here. And now to go over the actual method and why we did vectors first is we notice that once we do this multiplication, we're going to get the output, we'll get a 3 by 4 matrix. Okay? Because like I say, you cancel the 3's in the middle and you're left with a 3x. Well, you can cancel this x as well, 3x4. Okay? But how do we do this? This means that the matrix will have 4 columns. So we just work out each column individually. How do we work out each column individually? Well, we'll write down the first column, and we'll say that this is equal to 1, 2, minus 1, 3, 0, 4, and 2, 2, 2, multiplied by 1, 2, 3. Okay? So what did I do here? To get the first column of the product will be given by putting the first column of our right matrix into our left matrix. Okay? And since we know how to do vector multiplication, this should be pretty easy. So this becomes 1, 2, minus 1, plus 608, plus, well, it's the thing here actually. We just did this example. So I'll just go with it. It's 13, 8, 13. And then we're just going to repeat this process for each of the columns in the right-hand matrix here, okay? So here we're going to get the second column. And the only difference is we replace the first column of our right-hand matrix with the second column of the right-hand matrix. So we get 2, 1, 1 here instead. Let's work out what we get. So it's 2, 4, minus 2, plus 304, plus 2, 2, 2. Because remember, we multiply each of the rows, the columns by the corresponding entry in the vector. So we double the first and then just add on one copy of each of the others. So this is 4, 7, 6, 0. Okay, that's the second column. For the third column, we're running out a little bit of space. The third column is 102. That is the third column of the matrix on the right there is 302. So let's just tidy this up a bit. So let's just make sure I'm right. I'm getting this 102, remember, from this matrix here. We're looking for the third column now, so we look at the third column of the right matrix. Okay, and again, it's very easy. It's just 1 times the first, 0 times the second. So we'll just, well, we can put in 0 times 304 here. This will come out to be 0. Plus 2 times this will just be 444. What does this equal to? 5, 6, 3. And that's our third column. So that's the third column. And lastly, let's just grab the fourth. The fourth column is just 1, 1, 1. So let's just grab this equation and replace the column in the side with 1, 1, 1. Except here we also want to replace this with 1, 1, 1. But 1, 1, 1 is quite easy. It means we just 1 times the first, plus 1 times the second, plus 1 times the third. This is equal to 1, 2, minus 1, plus 304, plus 2, 2, 2. So this is 5, 6 on top, 4 in the middle, and 5 on the bottom, right? So now that we've gotten, let's just see if we can zoom out a bit. So now, notice we've done this calculation 4 times for each of the 4 columns that we'll get in our output space. So therefore, this implies this is equal to the matrix, sorry, the product over here is equal to that. 13, 8, 13, 2, 1, 1, 7, 6, 0. Oh, sorry, this isn't my mistake. This shouldn't be a 2, 1, 1. this should be, the second column is 760, I should say, from our calculation. And this is 5, 6, 3, and 6, 4, 5. Okay, and this is our product from this matrix over here. Okay, so matrix multiplication can be a bit cumbersome sometimes, but as long as you break it down into individual vector matrix multiplications, it becomes a lot easier, and you can just work out each column individually. Okay, this was Connor Mead with the Calculation Center, and I hope to see you in the next video.